Hi, good morning everyone. Good morning sir, my name is Linyarica M. Rapsing, ABS Ed Math student. So, today I'm going to talk about statistics, or the basic concepts of statistics. So, what are the words you think of whenever you hear the word statistics? So, in the next slide, I will show you a picture with words in it that are linked or connected to the word statistics. So, the words such as collection, data, interpretation, theory, scientific, samples, analysis, and many more are the words that are linked to the word statistics. So first off, what is statistics? So statistics is a collection of methods for collecting, displaying, analyzing, and drawing conclusions from data. It is also the science of gaining information from numerical and categorical data. So every day we encounter numerical information from a news or a magazine or a news magazine with data in it. So it would not be possible without statistics, since it is the process of collecting data in order to analyze and interpret the results and for us to make judgments on it. So statistical methods can be used to find answers to the question like what kind and how much data needed to be collected. How should we organize and summarize the data? How can we analyze the data and draw conclusions from it? And how can we assess the strength of the conclusions and evaluate their uncertainty? So furthermore, statistics is the science of dealing with uncertain phenomenon and events. Statistics in practice is applied successfully to study the effectiveness of medical treatments, the reaction of consumers to television advertising, the attitudes of young people towards sex and marriage, and much more. It's safe to say that nowadays statistics is used in every field of science. So let us next slide. So another concept which is linked to statistics is the word population and sample. So population, which means all members of a group about which you want to draw a conclusion. So, for example, all U.S. citizens who are currently registered to vote, or all patients treated at a particular hospital last year, or the entire daily output of a cereal factory's production line. So a sample is the part of the population selected for analysis. So for example, the registered voters selected to participate in a recent survey concerning their intention to vote in the next election, or the patients selected to fill out a patient satisfaction questionnaire, or 100 boxes of cereal selected from a factory's production line. So the parameter is a numerical measure that describes a characteristic of a population. So for example, the percentage of all registered voters who intend to vote in the next election, or the percentage of all patients who are very satisfied with the care they receive, or the average weight of all the cereal boxes produced on a factory's production line on a particular day. So the source of each measurement is defined as sampling unit, or simply a unit. So the source of each measurement is defined as sampling unit or simply a unit. Next is variables, a characteristic of an item or an individual that will be analyzed using statistics. So we have two types of variables, which is categorical or qualitative variables, or numerical or quantitative variables. So categorical variables are the values of the variables the values of the variables are selected from an established list of categories. So, for example, gender. It has a category male and female. Or academic major, a variable that might have the categories English, Math, Science, and History, and among others. So numerical variables are the values of these variables involve a counted or measured value. So discrete variables are counts of things. Continuous values are measures, and any value can theoretically occur, limited only by the precision of the measuring process. So for example, the number of previous presidential elections in which a citizen voted. It is a discrete numerical variable since it is a exact measure of things, while continuous values is the household. For example, the household income of a citizen who voted. Since a household income cannot be permanent or can change over time. So, besides from being classified as either qualitative or quantitative variables, so we also have scales, which gives certain structure to the variable and also defines the meaning of the variable. So under scales for qualitative variables, we have nominal scale and ordinal scale. So nominal scale is if the categories are unordered, then the qualitative variable is said to be defined on a nominal scale. So for example, occupational categories, since they have no natural ordering. So, if the categories can be put in order, then it is said to be an ordinal scale. So, for example, education, which can be classified as low and high. Strength of opinion on some proposal, which can be classified as whether indifferent towards it or opposes it. And the position at the end of the race. For example, first, second, and etc. So scales for quantitative variables can be discrete or continuous. Aside from it, we have interval scale or ratio scale. So if one can compare the differences between the measurement of the variable meaningfully, but not the ratio of the measurements, it is said to be an interval scale. So for example, measures the temperature measured on the centigrade system. It can be measured but not the ratio of the measurements. While the height of a person is a ratio variable because you can differentiate and can interpret the measurements meaningfully. So next is data. So the information collected to be studied with. So the collection of these observations is called a data set or a data matrix. So next slide we have sources of data. So we have three sources of data, which are published sources, experiments, surveys. So all statistical analysis begin by identifying the source of data. Among the important sources of data are these. So for example, we have published sources. These are data available in print or in electronic form, including data found on internet websites. So primary data sources are those published by the individual or group that collected the data, while secondary data sources are those compiled from primary sources. So for example, an agency, many Philippine agencies made or published primary data sources that are available on their websites, while business news sections of daily newspaper commonly publish secondary source data compiled from these government agencies' data. So, you should always consider the possible bias of the publisher and whether the data contain all the necessary and relevant variables when using published sources. Remember too that anyone can publish data on the internet. So next is experiments. So it is the process that studies the effect on a variable of varying the value or values of another variable or variables while keeping all other things equal. So a typical experiment contains both a treatment group and a control group. The treatment group consists of those individuals or things that receive the treatment being studied. The control group consists of those individuals or things that do not receive the treatment or treatments being studied. So, for example, a pharmaceutical companies use experimental studies to determine whether a new drug is effective. So, a group of patients who have many similar characteristics is divided into two subgroups. So, members of one group, the treatment group, receive the new drug, while members of the other group, the control group, receive a placebo or a substance that has no medical effect. So, after a time period, statistics about each group are compared. So, proper experiments are either single blind or double blind. So a study is a single blind experiment if only the researcher conducting the study knows the identities of the members of the treatment and control group. If neither the researcher nor study participants know who is in the experiment treatment group and who is in the control group, the study is a double blind experiment. So when conducting experiments that involve placebos, the researchers also have to consider the placebo effect. That is whether people in the control group will improve because they believe that they are getting a real substance that is intended to produce a positive result. When a control group shows as much improvement as the treatment group, the researcher can conclude that the placebo effect is a significant factor in the improvement of both groups. So another is surveys. So it is the process that uses questionnaire or similar means to gather values for the responses from a set of participants, which is very familiar to us. So for example, a group of students conducted a research and handed out questionnaires, or a website with a poll. So that's it. So surveys are either informal, open to anyone who wishes to participate, targeted, directed toward a specific group of individuals, or include people chosen at random. The type of survey affects how the data collected can be used and interpreted. Frequency or count, which is the number of observations that fall into a particular class of the qualitative variable. So relative frequency distribution is a table listing all classes and their relative frequencies. Cumulative frequency distribution is obtained by summing the relative frequencies of all classes up to the specific class. So the qualitative data are presented graphically either as a pie chart or as a horizontal or vertical bar graph. The pie chart is a disk divided into pie-shaped pieces proportional to the relative frequencies of the classes. A horizontal bar graph displays the classes on the horizontal axis and the frequencies or relative frequencies of the classes on the vertical axis. So next, we have branches of statistics. We have two types of branches of statistics. which are descriptive statistics and the inferential statistics. So descriptive statistics is the branch of statistics that focuses on collecting, summarizing, and presenting a set of data. So, descriptive statistics, for example, the average age of citizens who voted for the winning candidate in the last presidential election, or the average length of all the books about statistics, or the variation in the weight of 100 boxes of cereal selected from a factory's production line. So you are most likely to be familiar with this branch of statistics because many examples arise in everyday life. Descriptive statistics forms the basis for analysis and discussion in such diverse fields as securities trading, the social sciences, government, the health sciences, and professional sports. A general familiarity and widespread availability of descriptive methods in many calculating devices and business software can often make using this branch of statistics seem deceptively easy. So inferential statistics is the branch of statistics that analyzes sample data to draw conclusions about a population. So for example, a survey that sampled 2001 full or part-time workers ages 50 to 70 conducted by the Philippine Association of Retired Persons, or discovered that 70% of those who plan to work past the traditional mid-60s retirement age. By using methods discussed, the statistics could be used to draw conclusions about the population of all workers ages 50 to 70. So when you use inferential statistics, you start with a hypothesis and look to see whether the data are consistent with that hypothesis. Inferential statistical methods can be easily misapplied or misconstrued. And many inferential methods require the use of a calculator or computer. So we have sampling concepts. So first of, what is sampling? So sampling is the process by which members of a population are selected for a sample. So for example, choosing every fifth voter who leaves a polling place to interview, drawing playing cards randomly from a deck, or polling every 10th visitor who views a certain website today. So the method by which sampling occurs, the identification of all items in a population, and the techniques used to select individual observations all affect sampling. So probability sampling is a sampling process that takes into consideration the chance of occurrence of each item being selected. So probability sampling increases your chances that the sample will be representative of the population. So for example, the registered voters selected to participate in a recent survey concerning their intention to vote in the next election, or the patients selected to fill out a patient satisfaction questionnaire, or 100 boxes of cereal selected from a factory's production line. So you should use probability sampling whenever possible because only this type of sampling allows you to apply inferential statistical methods to the data you collect. In contrast, you should use non-probability sampling in which the chance of occurrence of each item being selected is not known, to obtain rough approximations of results at a low cost or for small scale initial or pilot studies that will later be followed up by a more rigorous analysis. So surveys and polls that invite the public to call in or answer questions on a web page are examples of non-probability sampling. So next is simple random sampling. So the probability sampling process, in which every individual or item from a population has the same chance of selection as every other individual or item. Every possible sample of a certain size has the same chance of being selected as every other sample that has that size. So for example, selecting a playing card from a shuffled deck, or generating a number by throwing a pair of perfect dice, or using a statistical device such as a table of random numbers. So simple random sampling forms the basis for other random sampling techniques. The word random in the phrase random sampling may confuse you if you think that random implies the unexpected or the unanticipated, as the word often does in everyday usage. However, in statistics, random implies no repeating patterns, that is, in a given sequence. A given pattern is equally likely or unlikely as another. From the sense of equal chance and not unexpected or unanticipated comes the term random sampling. So we have frame. So the list of all items in the population from which samples will be selected. So for example, voter registration lists, municipal real estate records, or customer or human resource databases, directories. So frames influence the results of an analysis, and using two different frames can lead to different conclusions. You should always be careful to make sure your frame completely represents a population. Otherwise, any sample selected will be biased, and the results generated by analysis of that sample will be inaccurate. Sample selection method. So proper sampling can be done with or without replacements. So sampling with replacement, in which a method in which each selected item is returned to the frame from which it was selected, so that it has the same probability of being selected again. So for example, selecting entries from a fishbowl and returning each entry to the fishbowl after it is drawn. So sampling without replacement is a sampling method in which each selected item is not returned to the frame from which it was selected. Using this technique, an item can be selected no more than one time. Selected numbers, for example, in state lottery games, selecting cards from a deck of cards during games of a chance such as blackjack. So sampling without replacement means that an item can be selected no more than one time. You should choose sampling without replacement over sampling with replacement because statisticians generally consider the former to produce more desirable samples. So next we have skewness. Skewness is used to summarize a sample of population. So we have different types of skewness. The bell and U-shaped distribution are symmetrical. On the other hand, the skewed to the right or skewed to the left is a non-symmetrical distribution, according to which tail is longer. So the bell-shaped and U-shaped distribution are symmetrical, which means it has a normal distribution of the frequencies of the data, while skewed to the right means a high distribution, while skewed to the left means low distribution. Next, we have measures of central tendency. It is a single value that attempts to describe a set of data by identifying the central position within that set of data. So we have mean, the sum of all values divided by the total number of values; median, the middle number in an ordered data set; and the mode, the most frequent value. So a hypothesis in general is an assumption that is yet to be proved with sufficient pieces of evidence, while a null hypothesis thus is the hypothesis a researcher is trying to disprove. So a null hypothesis is a hypothesis capable of being objectively verified, tested, and even rejected. So therefore I conclude that is the end of my report. Thank you.